So this is to continue on with our notes. So now we're looking at instruments called an electroscope. And what it does is it just detects the presence of positive and negative charges. And I think I should be able to show you one. But basically, it's some sort of device that holds on to two, oh, my smartboard.
Why did it get off so bad?
You know, yesterday morning I aligned it, and by the afternoon it was off. And I didn't even touch my smartboard. I didn't move it or anything. Total. Oh, it's still off. So it's basically just a ball, and it has a wire that holds two metal leaves together.
Oh, we've seen that.
Yeah, we have.
Yeah, they're like. Oh, yeah.
So this is our high-tech electroscope. Oh, there's big one.
Oh.
So this is what we're talking about here. And so, just to show Mac, this is what we're talking about here. This is an electroscope. And so what happens is you would take a rod and you would charge it. So is plastic a conductor or an insulator?
Insulator.
Plastic?
Is it? I would say.
It conducts electricity.
Well.
Well, it should. But let's see. Very broken lots of these because the tables are not level.
That's just
I know. So see how you can see the leaves move?
You can see that?
And you can even see it on the fur on the rod, right? And then once I touch it, okay? What about glass? You might actually have to move, Sophia, and not be ignoring that.
Sucker. Glasses and conductor.
Yeah. And then the other one, if we were to use wood, is wood a conductor?
No.
A little bit.
A little bit.
And you can see it on here. Okay, well I'll do it so that Mac can see maybe.
Hey, Mac.
So if we did plastic, whoops.
Oh.
So you can see it move a little bit. So there's some kind of charge there. Glass. Ooh, macro. Whoops, I touched that one. And then wood. And you can see that there's no charge. Now the reason that we saw a charge before is because I left the hairs of the fur on here, which is carrying the charge. So when I shook it, I got the hairs off, which got rid of the charge. Okay? So that's an electroscope. So a positively charged rod attracts electrons, because remember, we're always talking about the movement of electrons, to the head of the electroscope, leaving the leaves positive, and therefore they will repel. A negatively charged rod will repel electrons from the head of the electroscope into the leaves, leaving the leaves negative, and therefore they will still repel. So this is what it looks like. Let's call this neutral position. So if we were to take this and we bring in a rod, we don't touch it, but it's positively charged, what are we going to see here in the head of the electroscope?
All the negatives are going to be over.
The negatives are going to go here, and so then the positives we find line up down here. So it's not, there's no movement of electrons, this is the rearranging of electrons, okay? So then what we see is these leaves repel out to here. And we call that electrostatic repulsion. And we can see where those words are coming from. We see that there's a charge, so we have the electro part of the word, and we can see that it's through friction, which is static, so electrostatic. Then if we did the same thing with a negatively charged rod, brought it close to the head of the electroscope, we're going to see that the negatives are going to line up along the leaves, and two similar charges will repel. So these leaves will fan out, and again you'll have, and again it's electrostatic repulsion. So here, when we're realigned, when we see that the electroscope rearranges itself, the electrons are going to move up. Okay, in this particular position, what happens to the electron movement? In this one here. Which way did the electrons go here? Down. Okay? Make sense so far? We're always talking about the movement of electrons. Okay? Okay. So if an electroscope is charged, we use it for determining the nature of the object. So if we induce a charge on the electroscope, it can be accomplished through grounding. So we're going to show that through diagrams like this, the electroscope with the leaves, and then we're going to use the grounding symbol. And what do we see with a grounding symbol? What's going to move?
Electrons?
The electrons will move. And which way will they move, do you predict? Up and where? Up just into the head of the electroscope?
Oh, up and out.
Up and out. Okay? So that's what this looks like. If we were to bring in a negatively charged rod, what we see, oh, and this is grounded. What we see is that the electron flow goes this way. Okay? And the electrons are moving due to what kind of repulsion would that be?
Electrostatic repulsion.
Electrostatic repulsion. So then if we were to remove the ground, once we have seen this repulsion and we take the ground away, so we still have our rod that's full of negative charges, and we have our electroscope that's full of positive charges. This is what stays when we take that ground away. The electroscope stays with an overall positive charge. Okay? So we remove the ground. We've left the rod there. And then we take the rod away. So we've charged it with the grounding wire attached to it. Then we remove the ground. We see that it has a positive charge, but we've left the rod there. So what happens is, even though we take the rod away, our electroscope has a net positive charge. Okay? So the electroscope stays positively charged. Okay, so we say that the electroscope has a permanent positive charge. Now I put permanent in quotation marks because this was electrostatically charged, and we know that eventually through time static will wear off. The charge will eventually dissipate through the atmosphere, so we would see the electroscope go back to a neutral position over time. Make sense so far? As long as you can keep in your brain that we have electrons moving. What kind of environment is this? Friction, induction, or conduction? Induction. Yeah. Because we brought the rod close, but we never touched it. Okay? You're good, Cameron? Okay. So let's look at some examples. If an electroscope is positively charged, determine the charge on the rod. So we have an electroscope. Okay, we have an electroscope and it is positively charged. Determine the charge on the rod. Okay? So here we have an overall positive charge. What do we think is going to look like in this diagram? How could we determine what this rod's going to look like? You think the rod is negative?
Yeah.
So which way would the electrons flow?
They come off. No, I don't know.
What do you think? Hazard a guess. What do you think?
Is this thing grounded?
No.
I think the rod's negative.
You think the rod's negative?
Yeah.
You think the rod is negative? Okay, well Jaden was right about this part. If it's positive, you're going to see the electrons flow this way. Okay? But in order for electrons to flow, it has to go not towards more electrons, because that would be repulsion. Do you see where I'm going with that? Okay, in order for your electrons to flow, the rod has to be positive. If we put the rod as negative, would the electrons flow to the negative charge? We've just said positives will repel. We'll see these leaves repel. Because they're a like charge. They're both positive. Both leaves are a positive leaf. So the leaves are going to repel. And you have to have electron flow. You don't want the electrons to repel. They need to be attracted to something. So the electrons are going to have to flow into a positive rod.
And how do we know if the electrons are flowing that way?
Because they've got to move. They've got to move. It doesn't matter. Even if they were to flow this way, it would have to be, this would still have to be positive for the electrons to move from here to here. To have electron flow, you have to go from a positive, like it has to be the two charges. So you could have it be this way. You could have it be this way, Cameron. You're saying, why can't the electrons flow this way? You could, but your rod still has to be positive. And this would have to be positive for your electrons to flow. If this was negative, your electrons would not flow. There would be repulsion. So what we're doing is we're doing the last step, but we're just taking out all the steps in between, the last example. We're just taking all the steps in between. Okay?
So you're saying that the positive charges flow up to
No.
the rod?
The electrons flow.
Oh, you just didn't write down any electrons.
I didn't put any electrons in there. I didn't. But for that rod, if this is positive,
Yeah.
you have to have electron flow. Somehow you have to have electron flow. Whichever way they're going to go. It can go this way, but the rod still has to be positive. Because you can't have electrons go from a negative to a negative. It has to go from a negative to a positive. Which then means that this aligns up
So
with
this
your
question
positives
is
there.
saying that like at the beginning it was neutral. We added a rod that we don't know the charge of, and now the electroscope's positive. Figure out what the rod's charge.
Yeah, let me just keep writing down what goes with this electron flow. Because I just wanted to show that you were right in saying the electrons move that way. Okay? So electron flow is up. Okay? In order for the leaves to stay positive, electron flow has to stay up. And so therefore, for electrons, for electrons to move, they have to be attracted to a positive charge. Okay? do we understand this idea of the electrons moving towards the positively charged rod? Because you have to have movement of electrons. Always there's a movement of electrons, whether it's in rearranging on the rod itself or an actual transfer. There's got to be a movement of electrons. Okay? So the next one is a little bit different. An electroscope is negatively charged and a positively charged rod is brought near the electroscope head. Determine which way the leaves will move. So here we have our electroscope, and it is negatively charged. Okay? So this has an overall negative charge. So, here we have our electroscope, and we brought in a rod that's positively charged. Determine which way the leaves will move. So which way is our electrons going to move?
They'll move up.
They will move up.
And then the positive charges go down to the leaves.
Positive doesn't move. Electrons will move up to the rod. So that part was correct. So what are we going to see these leaves do then? They're already spread apart, right? There's repulsion there.
They come together.
They come together. Okay? We've seen the electrons move up into that rod, and so because there's less of them, they're going to come closer together. They might not go back to a neutral charge, but they won't be as far out as they originally were. Okay? So now this gives you the opportunity to work on question number 10 on page 84. So if you haven't gotten questions 1 through 9 done, here's also your opportunity to finish that part.
Ooh.